The question says 20.00 centimeter cube of a solution containing 0.53 grams of anhydrous sodium carbonate in 100 centimeter cube requires 25.00 centimeter cube of tetrazosulfate 6 acid for complete neutralization. The concentration of the acid in moles per dm cube is dash. When we have the atomic mass of hydrogen to be 1, carbon 12, oxygen 16, sodium 23, and sulfur 32. Solution. The first thing to do in any question involving a chemical reaction is to write out the equation. Here we are dealing with a neutralization reaction. So we'll be reacting the acid with the base to give us salt and water. But in this case, we have carbonate present. So we'll also be having carbon dioxide as a product. So let's go on. So here we have the acid, tetrazosulfate 6 acid, reacting with the base, sodium carbonate, to give us the salt we'll be having here is sodium sulfate. We have water and then carbon dioxide. So after writing out the chemical equation, the next thing to do is to check if it is balanced. So let's start with hydrogen. We have 2 atoms of hydrogen present on the reactant side. Then the product side we have 2 as well. For sulfur we have 1, and here we have 1 as well. For oxygen we have 4 plus 3 here, that's 7. So let's check here. We have 4 plus 1, that's 5 plus 2, 7, balanced. Then the sodium, we have 2 atoms of sodium present, 2 present here as well. That's balanced. We have 1 atom of carbon, and checking the product side we have 1 as well. For the oxygen, we've checked that earlier, it is balanced. So then we can say this is a balanced chemical equation. After writing out the chemical equation, the next thing we'll be doing is to write out the formula we'll be using. For any question that has to do with neutralization or titration, the formula we'll be using is CAVA over CBVB will be equal to Na over Nb, where Ca is the concentration of acid used, Va is the volume of acid used, Cb is the concentration of base, Vb is the volume of base, Na is the number of moles of acid, and Nb is the number of moles of base. Having written out the formula, the next thing to do is to write out the data given from the question. So from the question now, Ca is unknown, Va is 25.00 centimeter cube, Cb is unknown as well, Vb is 20.00 centimeter cube, Na is 1. Our Na is gotten from the equation, that is the coefficient of the acid present in the equation. Here we have 1. So for Nb as well, it is 1. We have Nb to be 1. So having done this, we'll discover that the concentration of the acid is unknown and the concentration of the base is unknown as well. So what do? So from the question, we can calculate the concentration of the base in moles per dm cube, being given the concentration of the base in grams. So we have the concentration of the base to be 0.53 grams in 100 centimeter cube. We do not know the concentration in grams per dm cube, and we do not know the concentration in moles per dm cube. So the next thing we'll do here is to calculate the concentration of the base in grams per dm cube. So we'll do that by saying 0.53 grams sodium carbonate to be present in 100 centimeter cube. So what mass? So we say X grams of sodium carbonate will be present in 1000 centimeter cube. We are doing this to know the mass concentration of sodium carbonate, that is to know the mass present in 1000 centimeter cube. And mind you, 1000 centimeter cube is equivalent to 1 dm cube. So we have H to be 0.53 grams times 1000 centimeter cube divided by 100 centimeter cube. So when we calculate this, we have X to be 5.3 grams. Hence, we can say that concentration of Na2CO3 is then 5.3 grams per dm cube. That is, we have 5.3 grams of Na2CO3 in 1 dm cube, that is 1000 centimeter cube. Now we've gotten the concentration in mass of sodium carbonate, but we are still finding the concentration in moles per dm cube. So to get the concentration of the base in moles per dm cube, we'll be using this formula. Molar mass equals mass concentration divided by molar concentration. Since we are looking for the molar concentration of sodium carbonate, we'll be making the molar concentration the subject of the formula. So here we say molar concentration equals mass concentration divided by the molar mass. We have the mass concentration of sodium carbonate to be 5.3 grams per dm cube, and the molar mass, we'll be calculating the molar mass. So molar mass of Na2CO3 we have 2 atoms of sodium present, so we're saying 2 times 23 plus 1 atom of carbon present, 12, plus 3 atoms of oxygen, so that's 3 times 16. We have 46 plus 12 plus 48, which gives us 106 grams per mole. We can proceed from here, and we say molar concentration of sodium carbonate the mass concentration which is 5.3 grams per dm cube, divided by the molar mass, 106 grams per mole. Let's calculate this. Here we have 0.05 mole per dm cube. So this is just the first part of the question. Don't forget we are still using the formula CAVA over CBVB, which is equal to NA over NB. So we've gotten CB and CA is unknown. So coming back to where we started earlier, our CA is unknown and our CB is unknown. So from the calculations we did, we've gotten CB, the concentration of the base, while CA is left unknown, and that is what the question says. The concentration of the acid in moles per dm cube is dash. That's what we'll be looking for. So to know the concentration of the acid in moles per dm cube, we'll be making Ca the subject of formula. So here Ca equals CBVB Na divided by VANB. Then Ca equals, so let's substitute the values. The concentration of the base is 0.05 mole per dm cube. Multiplied by the volume of the base, which is 20.00 centimeter cube. Multiplied by the number of the moles of the acid, which is 1, divided by VA, 25.00 centimeter cube, and NB is 1 as well. So here we have 1 over 25 mole per dm cube, which is equal to 0.04 mole per dm cube. And this can also be written as 0.04 molar. So that answers the question. So here we've gotten the answer to the question. So here we can see that the concentration of the acid in moles per dm cube is 0.04 moles per dm cube. And that will be all on that.